Radio or click the Twitter icon on our homepage. You can also friend us on Facebook. Just search Progressive Radio Network. Always new and up to date. The Progressive Radio Network, your home for thoughtful and informative information.
Everyone, I'm Gary Null, broadcasting and video streaming live from our studios in New York City. This is the Progressive Commentary Hour, where we take on a single issue with experts in the field to provide information and insight that I believe the mainstream media has chosen not to make a priority. Today, the issue is tipping points. Now, there are different tipping points, and they change from time to time, some being added, some being taken away. My panelists who will be discussing this include Professor Henry Pollack and his colleagues on the Intergovernmental Panel on Climate Change. They shared a Nobel Peace Prize with former Vice President Al Gore. Professor Pollack is a professor emeritus of geophysics at the University of Michigan, where he has taught for over 40 years. He travels regularly to Antarctica and has conducted scientific research on all 7 continents. He now serves as a science advisor to Al Gore's climate project. He is the author of Uncertain Science, Uncertain World, and his most recent book is A World Without Ice, which explores how, for the first time in human history, the delicate relationship between human growth, rising industrial economies, and a remaining ice is going to cause a dangerous situation. My next guest will be Dr. Sylvia Earle. Dr. Earle is one of America's great oceanographers and explorers. She has been called a living legend by the Library of Congress. Dr. Earle is presently the National Geographic Explorer in Residence and chair of the Advisory Council for the Heart Research Institute and Ocean in Google Earth. She has led over 400 marine expeditions and holds the world's record in women's solo diving. She has earned over 100 awards for her work in ocean exploration, and she's been hailed as a hero for the planet by Time magazine. She's written numerous articles, many books. Her latest is The World is Blue, How Our Fate and the Oceans Are One, perhaps one of her most important books, summarizing her career in acquiring deep knowledge about the oceans and their relationship to a sustainable life for humans on Earth. And my final panelist will be Professor David Montgomery. Professor Montgomery is a geomorphologist and environmentalist in the Earth and Space Sciences Division at the University of Washington College of the Environment in Seattle. He specializes in the evolution of geological topography and the influence of geomorphological processes on ecological systems and human societies. His research is taking him worldwide, the Cascade Range in the Pacific Northwest to the Andes to the Himalayas to the Tibetan Plateaus. His latest publication is Dirt, the Erosion of Civilization, which is a very important study about the role soil and erosion play. And a second inconvenient truth has played in the rise and collapse of civilizations and society. That represents our panel. Now a little overview before we go to each person to begin our discussion. Currently, more than half of the American population, when polled, said they do not believe that global warming is real or that it is man-made. Most discussions involving our environment rest upon global warming as a single issue, as if nothing else were bothering the environment. However, we are confronted today with multiple environmental crises. Any one of these issues can cause extreme suffering, and in some cases could become cataclysmic in its devastation if we were not to pay attention to its consequences. Hence, we present an exploration of these tipping points to better understand the dangers that we face and how our behavior and actions can hopefully limit the negative consequences. Now, we will not explore all these in depth, but we will certainly explore some. Not all have tipped. For example, the disruption of the Antarctic circumpolar current, the release of methane clathrates, the disruption of the monsoon season, El Nino, the shrinking of the Sahara Desert, the collapse of the Arctic circulation belt, the collapse of the West Antarctica ice sheet, which is tipping, and also the melting of Greenland's ice sheet, which is also in the process of tipping. But again, we do not know how long it'll take, but we'll explore that. The death of the Amazon rainforest. You would think that more people today would be aware of the consequences of deforestation, but almost all surveys show people are not aware and assume that anything that's deforested is being replanted and everything will green out again. Also tipping is the disintegration of our ozone layer, the decline of glaciers on the Tibetan Plateau, and the diminishing of ocean salinity. All of those are tipping except the first ones I mentioned to you. Let us go now to our guest so that we can begin our exploration of these. We'll begin with Professor Henry Pollack. Nice to have you with us today, sir.
Thank you very much, Gary. I'm pleased to be with you again.
Let us begin and assume that some people are listening to this for the first time. I want to give them a little background, if you would, and then with each one of the crises that we're facing, if you could, and I'm going to ask all three of our panelists to do the same, if you would, please, and I welcome all of you, please give us in lay language what this actually means, how it might impact them at some point in the future or someone in the future, and then give us an idea in all of your discussion, what can we do in a proactive and positive way politically, individually, and collectively? Let's say our body politic chooses not to address any of these and to kick it down the road, as they've been doing for a long time. But we are concerned citizens and we want to do something. Then try to give us the best ways we can approach this, and then working together, try to make some impact. And if all else fails, where are some places we don't want to be if these things begin to tip out of control? So with that said, you've, Professor Pollack, you've recently returned from a trip to the polar station in Antarctica. I'd like you to tell us about your experience there and what you've learned from the research being conducted in Antarctica that should alarm us about melting trends and what consequences we will be facing as these trends continue.
I'd be pleased to do that. I did just return a week ago from the Antarctic Peninsula, along with Professor Earle as well. And we saw the changes taking place in the Antarctic Peninsula where temperatures, particularly wintertime temperatures, have risen dramatically. Sea ice is now forming only in a couple months as opposed to 6 months along the west side of the Antarctic Peninsula. And glaciers that feed off of the peninsula into ice shelves and into the sea are shrinking back. And all of this is apparent as you approach Palmer Station, the U.S. research station on the Antarctic Peninsula. And the consequence that of this change in temperature and change in sea ice is that the life of the Antarctic Peninsula, the penguins, the seals, and the marine fauna that they feed upon, all of these are changing because the patterns of their ecology, of their environment, are changing. And so we're seeing big movements of certain species of penguins. We're seeing continued warming of the peninsula on the west side, and the ice is diminishing year by year. Formerly, 25 years ago at Palmer Station, there was a big glacier right up to the station, the Mar Glacier, and now it is shrunken several kilometers back. And so the landscape is changing, the ice is changing, the marine life is changing, and all of this is a canary in a coal mine for changes that are taking or will take place in other parts of the globe. So it's a very eye-opening experience to make our way south to see Antarctica, and particularly to hear from the researchers at Palmer Station of the changes that have taken place in the last 30 to 40 years.
Thank you for that overview. Anytime you mention the problems with the melting of the glaciers in Antarctica that brings fresh water into the ocean and can cause desalinization and rising of the ocean levels, one ocean around the world, you'll have the critics say, but that's going to take 300 to 1,000 years or longer, maybe even 10,000 years, so we needn't worry about it. And yet I remember when one group of climate denialists said that the Larsen B shelf had anywhere from 100 to 5,000 years before it broke, and it broke 29 days later. So now I would like for you to give us an idea of two things. First, what do you project, and I realize it's completely subjective, but what you project is the likely outcome of us going into some form of mathematical chaos modeling, where we simply cannot accurately predict how quickly this is going to melt, but it's melting faster than what our former models suggested. What does that mean as far as water going in and rising? Separately, recently when I was in Florida filming, I went for a run on the beach on the Atlantic side, and this was by Cocoa Beach, and I noticed that on the bottom of the buildings, 2 or 3 feet on, I saw seaweed. But I mean like a straight line, clear down this whole beach for about 10 miles. I went for a run. So I asked some of the people, at nighttime when the high tide comes in, did it always come in this high? Oh, no, that's something we've seen the last couple of years. Well, you realize that every one of these buildings are built on sand. There is no stone. And even though they have concrete pilings going down, it's still resting ultimately on sand, and sooner or later, a rising ocean is going to undermine the stability of this building, and it's going to cause cracks and may even make it unsuitable for living. They kind of shrugged and says, well, no one has complained, and nobody sees this as a crisis. And I'm thinking, whoa, look at Dubai. Aside from the fact Dubai is bankrupt and is $1 trillion in debt, look at all the architectural masterpieces that were built into the ocean on those fans, and multi-million-dollar homes, each one, but they were all built at sea level, where there's virtually zero opportunity for there to be a mistake, and yet the architects and the builders all say, not a problem. So I'd like to know, do you believe there is a problem with the oceans increasing? And last, give us your insight into what happens when the ice begins to melt and what we could be seeing with the polar ice sheets intact and not intact.
Well, that's a very good question, and some of the answers are very clear already. Sea level has been rising throughout the 20th century. It's not something for the future, although there is a future component to it, but it is a reality at the present day. Sea level rose about 8 inches in the 20th century, but the important thing is that the rate at which it was rising was accelerating towards the end of the 20th century and into the first decade of this century. And so the projections are that by the end of this century, sea level will be probably about 3 feet higher than it is today. And that is a big change. If the little creeping green line that you were seeing on the beaches in Florida was a few inches up on the walls of the structures, imagine what 3 feet of sea level rise would mean to coastal infrastructure and coastal buildings all the way around the world. So this is something that is already underway and is accelerating in its pace. Now, most of the sea level rise so far has come from the warming of the seawater, the thermal expansion of the seawater, and the new water that's coming into the oceans from the melting of mountain glaciers. Mountain glaciers are in the tropics, they're in the mid-latitudes, they're in the higher latitudes, and mountain glaciers everywhere, just as I mentioned, even on the Antarctic Peninsula, are retreating. And this retreat is contributing new water to the oceans, and that, along with the thermal expansion, is what is causing the bulk of the sea level rise today. Now, the bigger question is, what about some of the really big ice, not just on mountain glaciers, but coming off of Greenland and coming off of West Antarctica? Both of those have big stores of ice that, again, the glacier outlets along their periphery are showing acceleration, a more rapid discharge of ice into the sea. And I might point out, you don't have to wait for it to melt. If you just dump a new ice off of Greenland or off of West Antarctica into the sea level will go up. And it's like dropping an ice cube into a beverage glass. You don't have to wait for it to melt to see the level of the fluid rise. It happens as soon as you drop the ice into the liquid. And so we are concerned that the ice of Greenland and the ice of West Antarctica is becoming more unstable, and that the possibility of big discharges is becoming ever more a possibility. Excuse me. Now, the amount of ice on Greenland and the amount of ice on West Antarctica is about equal to about 20 feet of sea level from each of them. And so we certainly don't want to see that destabilization progress. And yet, right now, it is actually accelerating. So sea level rise, even at the 8 to 10 inches that we have already seen, is enough to make what would have been an ordinary storm surge half a century ago be a more potent storm surge just from an ordinary storm, and doing more damage than it might have before the sea level had risen. We saw some of that with Hurricane Irene just last fall, where the storm surges on the eastern seaboard were more severe than one might have imagined from the strength of the winds and the position of the hurricane. And so rising sea level, already in action, already causing problems that you called attention to in Florida, but ask the folks in Norfolk, Virginia, who live essentially at sea level. They are already seeing at times of big storms or at times of high tide the incursion of seawater into what was formerly dry land. So it's a real problem, and I might just add on a global basis that a rise of sea level of 3 feet in this century would displace 100 million people worldwide. We would call those people climate refugees. They would be forced to move from their homes close to the seaboard, and the social disruption, the social problems created by trying to relocate 100 million people worldwide is a problem of the first order. So there are huge consequences to sea level rise, and we've seen it already begun. And as you pointed out, a lot of people seem to pay no attention to it.
Okay. Please hold your thoughts. We're going to go over and introduce Dr. Sylvia Earle. Welcome to our program, Dr. Earle.
Oh, it's great to be on board.
Dr. Earle, would you please among the tipping points, the ocean conveyor belt, the thermohaline circulation in scientific terminology, is determined by the ocean's density caused by its salinity. Could you take us through this, please, and why we're now seeing this as a possible threat to different parts of the world, including Northern Europe? And also, if you would like to address, we have just had one of the coldest climate in Italy in its history. I have friends, in fact, I have some employees that just went back to Italy because they said in their lifetime it's never hit below zero in Rome. And it's been for 2 weeks and it's getting worse. Tell us about what happens to different parts of the world, including Europe, if this conveyor belt should be disrupted for any period of time.
Well, we take for granted this relatively stable envelope of circumstances that make our lives possible. And part of this has to do with the temperature regime that is magically suitable for the likes of us. When you think of the range of temperature throughout the universe, even within our own solar system, that we have just the right set of circumstances that suits humankind. And it's been remarkably stable over the last 10,000 years, during the time when civilization has really prospered as never before. So that there are now 7 billion of us. And the ways that we are pushing the envelope are really of concern, and that, of course, is what you're addressing here with these tipping point issues. And certainly high on the list of concerns are the ocean circulation that really has much to do with the temperature in various parts of the world. So that although Northern Europe would seem to be in an area, in a band that would be much colder than it actually is, the warming effect of the Gulf Stream coming up along the Atlantic and sweeping across the ocean, bringing warmer temperatures to Norway and the UK and elsewhere. If the circulatory system changes, the temperature of that part of the world would be affected as well. It's the concern is that the fresh water that is flowing from the melting Arctic
how bad could it be?
Change the pattern of circulation. Right now, the great currents that sweep the planet are driven in some large measure by the changes, the difference in salinity and the difference in temperature, driven, of course, on the surface by the winds and the rotation of the Earth. But all these things together have maintained the patterns that we have become accustomed to. This influx of fresh water at the top of the world in the Atlantic could cause a shift in the way these currents flow. True in the Antarctic as well. Globally, what we're seeing is a change that is unprecedented in the history of human civilization, driven, it appears, by circumstances over which we have some control. If we look through the long history of Earth, of course there have been sweeping changes. Ice ages have come, ice ages have gone, planet has been cooler, planet has been warmer. But what really concerns us right now is our influence on these patterns and how it is stressing the envelope of circumstances that makes our lives not just reasonable but possible. I can imagine, it is conceivable, that we could so alter the nature of these systems that maintain our life that it no longer is hospitable for our species. And it's not just what we're doing to add carbon dioxide and methane to the atmosphere, driving the temperature, which in turn is causing the accelerated melting of polar ice. It's the other sorts of impacts, all relating one to the other. Included are the loss of diversity that comes from what we're doing to forests, what we're doing to the ocean as well, destabilizing the integrity of systems that we have taken for granted during all preceding history, but presently we're seeing changes that are just without precedent. In my lifetime, I've seen the decline, for example, of coral reefs around the world by about half, either gone or in a state of decline, with a relationship to warming, but also a relationship to destructive fishing practices, overfishing, deliberate attempts to actually change the nature of some of these areas. The loss of phytoplankton throughout the ocean. This is of concern because of some very basic things, such as production of oxygen. We can still breathe. The level of oxygen in the atmosphere is still what it has been throughout human history and long before, about 20%. But with a decline of phytoplankton in the ocean, there is concern that great engine that grabs carbon dioxide and generates oxygen, drives food webs, maintains the kind of chemistry that is suitable for us globally, that we may find some unfavorable consequences as a consequence of this as well. The carbon dioxide that is driving planetary warming is also driving a phenomenon that is of growing concern, known as acidification of the ocean. This, too, what effects might this have on the plankton in the sea that generates oxygen and grabs carbon? Lots of questions that, for the very first time, we have the capacity to begin to measure, to even ask these questions. And I think with all the concerns, the bad news that is out there, if you will, I think part of the good news is that this is the first time in all of our history that we have the capacity to understand these changes and therefore might have the opportunity to take action and do something about it.
Let me add one question on to this, because I don't think people realize how important phytoplankton is, because it contributes up to 70% of the atmosphere's oxygen, and therefore it is within the greater scheme of the Holon or of the Earth or Gaia, and the necessary conditions for sustainability of that plankton in our oceans, and that's a major threat. But adding to that is the idea that we are not paying attention to salinity. Could you please explain salinity, what it means, what will cause that salinity to change, and what happens when the salinity changes?
The ocean generally has a salinity, it has saltiness of about 35 parts per thousand. And it's roughly equivalent to the salinity in our own bloodstream. Now, in some places the salinity is higher, in some places, especially in coastal areas where rivers dilute the basic salinity of the sea, it's lower. In fact, in some places like Chesapeake Bay, it's salty, but it is not anything as high a degree of saltiness as the open sea, the high seas, when you get way offshore, 100 miles or so, or even closer than that. Some creatures require a lower salinity. Mangroves, oysters, clams, or most favorably, in a circumstance where it's not full salinity, but something in the 20 or 25 parts per thousand range. The great estuaries of the world are in that lower salinity range, but there is concern that the lowering of salinity, especially in the polar areas, could alter the whole ocean circulatory system, that the concern that what we're seeing on our watch in our time is the level of change, the rate of change that is potentially something that could just alter some very basic patterns of temperature, patterns that are driving where people live, how they live, what we do. So I think it's one thing to be a witness, an observer of phenomena that are taking place, but I think what gives me cause for optimism and hope is that recognizing that we've got problems, that there are circumstances that we, among all the creatures on Earth, although there are others that have some forms of intelligence. I mean, cats and dogs and horses and elephants and whales and dolphins have some form of intelligence, but humans are kind of special in that we have the ability to act on what we know, to draw from our experiences in the past, to be able to measure in ways that other creatures cannot, to anticipate future consequences, to use the knowledge that we can acquire and are acquiring, and then modify our plans, our behavior accordingly. We can anticipate that changes in salinity in the ocean could have a range of consequences, and that we can act in ways that are more favorable to our future than would otherwise be the case. No other creatures have that power. What's frustrating to some of us, and I think some of us are gathered around this telephone right now, is the perversity of human nature, that even in the face of knowing, the acquisition of knowledge as never before, we couldn't acquire the kind of knowledge, insight that we now have when I was a child. Now we have the power through not only new sensors, new ability to get high in the sky and get these overview insights into the way the planet works and its impact back to us. We're being able for the first time to connect the dots between global warming, ocean acidification, human population, our food needs, the oxygen that we require, these tipping points that you're acknowledging. And yet this is maybe the last time we'll have, or at least the last best time we'll have, to do something about it. There is time to act, but only if we acknowledge that these patterns occur and that there are consequences back to us.
I appreciate those insights. Please hold your thoughts. We'll be coming back to you. Now let's say hello to Professor David Montgomery. Nice to have you with us today.
Thank you, Gary. It's nice to talk to you again.
David, let's go to an analysis and whatever projections you can give us about something that we do not consider day to day. The average American assumes that as long as there's food on the shelves, where it comes to us from and how it's grown is really irrelevant. Is it genetically engineered or organic? Is it local or comes 4,000 miles, the carbon footprint? We don't think about that. We don't think about 60 gallons of water to grow an organic potato and 3,000 gallons of water to grow the meat that goes in a quarter-pound hamburger, 12,000 gallons of water for 1 pound of beef. And when I look at these issues and I ask people, do you know where your food comes from? Do you know what is considered in this whole equation? The answer is no. I just care about that it's there. I buy it. I eat it. What else I need? And I ask people to take a deeper look at this. That said, I have some major concerns about American states that have mismanaged their resources, that have allowed massive over-industrialization and urban and suburban growth, far too many people for far too few resources, the most vital of which is water, but then we're also going through a massive erosion crisis in the United States. 16 states now cannot be sustained in their current configuration, meaning there's not enough water to supply them because the constant droughts and excessive heat in these states for the population, the industries, the infrastructure they have. And yet nobody wants to be the person that says, let us inform our population of our problem, that we have to start moving some people out or preventing people from coming in. They're not doing this. Then you look at China, that has had the second largest economic growth rate behind India, though it's declining substantially this year and will continue to decline, without any concern for the environment on any major scale, especially desertification. They'll show you that 16 of the world's 25 largest cities are in China. They'll show you beautiful designs of cities where millions of people live, and yet you ask them, do you have proper water supplies to sustain these people? Do you have ways of getting rid of the excrement and waste? Where are the foods being grown? And yet there's massive amounts of destruction of the water systems, the damming, and the soil erosion. It is humongous, but it's a big country. So again, as long as we're seeing only the bright lights, the industry, the Fox factory there pumping out 250,000 workers a day, we don't look at the things like soil, water, erosion. Could you take us through this journey, please, to show us what we have to learn about if we don't have the food, people will starve. If we don't have the soil and the water, we can't grow the food. So hence we're not looking at a land food sustainability around the world. Take us on this journey, please.
Yeah, as long as the lights are on and there's food in the grocery stores, most people won't really sort of pause and ask the questions that you're asking. But if you look back at the history of the civilizations that did not take care of their land and that did not steward their soils, it's really sort of a wreckage of past civilizations. You don't tend to think of modern-day Iraq as something that you describe today as the Garden of Eden. What happened? That same kind of story is played out in society after society that did not take care of this, what you might call the most fundamental of all resources, fertile soil. It's where our food comes from. Something like 97% of our food comes from the soil. And it turns out that soil is actually one of those natural resources that could be sustainable if we treated it in a way that allowed it to sustain our populations over the long run. But that's not what we're doing for the most part with modern agriculture, and in fact it's not what we did for the most part with agriculture in a lot of ancient societies. And the big problem, of course, in that regard is erosion, the physical removal of the soil. Soil you could think of as essentially the interface between the worlds of geology and the world of biology, the sort of the dead world of minerals and the living, bustling world of life, because life needs both the carbon that we get from plants that get it out of the atmosphere, but we also need a lot of the components of rocks that are broken down in soils and sort of enter the food chain from the bottom up, if you will. And really fertile land is able to support large biomass on top of it. You could think of soil as essentially literally the roots of ecosystems, and what we've been learning in the last few decades about the connections between life below ground and its ability to help sustain healthy life above ground are truly phenomenal. But we tend to treat land, and particularly in the way we farm in a modern sense, as if soil is essentially sort of a cheap industrial commodity, something just to hold the plants up as we add nutrients and we add fertilizers and biocides to essentially grow food. But that's not a pattern that is essentially really sustainable. If you look at the problem of feeding humanity in the coming decades, whether you want to call it 30 years or 200, to a geologist, that's all in the near term. It's a tipping point, if you will, in the sense of looking at the relationship of the planet to life on it. If we get to the point where we degrade soils so far that we may have a problem feeding ourselves as the dominant life form on the planet, that's a real potential sea change. How much of a real issue might that be? Well, the estimates are from over the last half century, we've lost already something like a third of our most fertile farmland, our most fertile potential cropland. And if you think about the problem of feeding the world of 10 billion people that people expect later this century, it would be really handy to still have that additional third of cropland with very fertile soils. When we enter a world in which oil starts to become increasingly expensive, odds are fertilizer prices are going to go up along with that. The whole ability to maintain the external inputs that drive modern agriculture seem to me to be increasingly unlikely to be sustained through the course of this century. And what's the alternative way to actually feed the world by the end of the century? It's to have as much fertile soil as we can muster on the planet. But that would require a large-scale shift to organic agriculture and so-called alternative agricultural techniques to actually conserve soil fertility as well as the soil itself. There's not a lot of new land we could go to actually start producing food to get it into the grocery stores so people could not think about where it comes from. Odds are, I think, by later this century, people are going to be worrying a lot more about where their food comes from. Because if you look at the amount of food we have on the planet at any one time now, it's less than a year's supply. We don't really have a lot of slack in our food production system, yet the population is expected to rise by another third to 50% later this century. It presents a real problem as to how we're going to actually feed everybody by the end of this century if we continue on the course of land degradation-style farming that we're currently practicing globally. And, of course, in the arid regions, in the areas subject to desertification, is where the issue will probably hit home first. And about a third of humanity lives in those lands that are potentially subject to that.
I have a friend from college that works with the government in a particular state that is having difficulty with water. And he shared something with me that two of the cities in that particular state are simply going to run so short of water based upon the depletion in their major aquifer feeding that they're going to have to tell the people, you're going to have to start moving, at least a lot of them, and certain industries going to have to be restricted. They're already on water restriction. And I said, why don't you just come out and just have a press conference and just be honest with people? He said it'd be political suicide. He says your value of your real estate would immediately collapse. There'd be massive lawsuits. No one wants to be held accountable. Nobody wants to tell society that there's a suicide pill that we have to take. And so as a result, politicians will inevitably get some scientist who will sign off on a report that says it's not that bad and get it till everyone's out of office. Or, down the road so far, you have plausible deniability. He said, but Gary, I got to tell you something. It's really bad. And I know it's bad. I've just finished traveling around the United States. So my thought is this. Do you believe, David, that we are going to see within the relatively near future major conflicts over land and water around the world?
If you give me this century as the relatively near future, I'd say it's a virtual certainty. And I think there's already places where land is scarce, water is scarce. Over the course of the next couple decades, of course, things become a lot more uncertain the shorter you make that time frame. But I think, the three things we really need as an organism are air, water, and food. And water and soil are at the heart of two of those. And the atmospheric changes are at the heart of the third, not in terms of what we have to breathe, unless the nightmare scenario about phytoplankton bears out. But I do think that we'll see increasingly conflict over access to land and water. The potential for conflict between China and India. If China starts damming the Indus or the Brahmaputra Tsangpo, the source of a lot of the water that helps to feed India, it doesn't take a whole lot of imagination to see the potential for conflict there in the future.
All right, I'm going to ask you, David, to address this first. Then I'm going to ask Henry if you would address this second. It's about glaciers. Most people don't think about glaciers because we think, well, they always have been these glaciers in human history, and they're going to be there forever. And yet satellite imagery shows that we are losing some of the polar glaciers at an accelerated rate, and we're losing a lot of the Tibetan plateau glaciers. And those who are in denial of this simply have to examine this. But on the ground, if you speak with people who will tell you how far they have to walk now to get to water that once was plentiful, it's substantial. And this is not in the last 100 years. This is the last 20 years. So would you each give us your ideas of plateaus? Because remember, the Himalayas and Tibetan plateaus provide the water, the runoff water, for about a third of the world's population. You're talking about India and Vietnam and China. And if they don't have the water, and clean water and abundant water, you're talking about 1.3 and about 1.27 billion people in each of these countries. There's going to be some problems. So would you each go with this? And David, you start, please.
Yeah, no. Even if you still have fertile soil, if you don't have water to water the crops, it doesn't do you a whole lot of good. I've done a lot of work up on the Tsangpo River on the edge of the Tibetan Plateau, and there's a particular glacier that I've worked on over it having dammed the river at some time in the past and made a great lake that failed, generating catastrophic floods down into India. But in talking with the locals there, that glacier had been down virtually near the river in the time not long after the Second World War, and now it's like miles back up the valley. It's nowhere to be seen. The state of Washington, where I live, many of the glaciers in the Cascades have receded greatly historically. But a glacier in the Himalaya is really like a natural dam in the sense that it is storing the water that falls as precipitation and holds it as ice until it melts off at the time of year when the farmers could really use it. How they would replace that resource is a real challenge. I mean, they're going to be in very bad straits if they lose essentially their summer water supply.
Well, India is short of water as we speak.
Yeah.
India's, in fact, if you look at two of the largest rivers in India, first they have enormous amount of pollutants in them because so many tens of millions of people in India, 740 million people, don't have indoor plumbing. But also because their infrastructure has not kept up with the way to decontaminate the water, to process it so it's usable to humans. You have people swimming in this water, bathing in this water, cleaning their clothes in this water. And if this was in the United States, no public health official would allow that to happen. This water would be considered too toxic, and yet there's nothing preventing these people from using it. And then farmers have been farming water, actually digging wells on their property, pulling up the water, taking it in and selling it. And now those are going dry. So explain to us what you see as the potential here of just simply running short of, potable water, drinking water.
Well, if you're losing your glaciers and you're mining your groundwater, you're in the process of essentially running out of water. Essentially, any kind of a system where if you use it up faster than it's being replenished, you're running out of it. It's just like the problem with the Ogallala aquifer in the western part of the Great Plains of the U.S., where we've been sucking water out of the ground that was put there back in the Pleistocene, the ice ages, or the land around Las Vegas, where they've been fueling the city on water by pumping it out of the ground. It takes a long time to replace it, and it's essentially an irreplaceable, or there's no substitute for water. I mean, humanity, unfortunately, is fairly good at adapting to degraded environmental quality, but there's simply no substitute for water. So it can't be good for a population to run short in that regard.
Also, Professor Pollack, would you address the same question, but I'm adding a little addition here. What about those companies that are privatizing water around the world, making it against the law for people to go out and even to collect through cisterns their own water, where the major move is let's privatize water everywhere, so whoever owns the water controls that resource. That, by the way, that's being done in Maine and other parts of the United States by some French companies, and with some terrible results. Your thoughts, please.
Well, let me first carry on with what David was saying about the loss of glaciers. The concentration of ice in the Himalayas and the Tibetan Plateau sometimes leads that to be called the third pole, because it is probably the third biggest accumulation of ice outside of the polar regions. And the irony of losing glaciers is that as long as there's any ice left, they keep supplying water, until the last bit is gone, and at that point it just turns off. And so it lulls one into a complacency that there's a problem that's impending, whether it's next year or next decade or next century. It doesn't capture your attention quite the way that if you are drawing well water and your well becomes less and less productive, it gives you a warning that you're in trouble. But there are places around the world where we have already lost the mountain glaciers. The Himalayas have the benefit of being high, and so the temperature change that's going to lead to their elimination is a little bit further into the future. But in the Andes, we've already seen in Bolivia and Peru, some glaciers disappear altogether. And in Africa, Kilimanjaro, the famous mountain with the snows of Kilimanjaro that Hemingway wrote about, that effectively has no ice on it anymore in the present day. So already we're seeing the loss of mountain glaciers. In the USA, Glacier National Park, when it was founded in the 1930s, it had more than 100 glaciers. Today there are about 15. And our children or grandchildren are going to ask us, Daddy, why did they name that Glacier National Park? So we're seeing ice diminishing in the mid-latitudes and in the tropics at a very fast rate, and it's certainly thinning and shrinking in the Himalayas as well.
One quick answer, if you would, Dr. Pollack. Explain to the people when the Arctic has ice and the sun hits and bounces back in the sky, that's one way that it expresses itself. But when that ice melts and it goes through the water, not that deep, about 500 feet, and starts to warm up the water, you have massive amounts of methane coming up that have been trapped down there for eons. And what that means when this methane starts percolating up.
What you're referring to, Gary, is principally taking place in the Arctic Ocean right now, where the ice over the Arctic Ocean is not hundreds and thousands of feet thick, but it's on the order of 5 to 10 feet thick. And in the summertime, it shrinks back some and breaks up some, but historically, there's always been an ice cover over most of the Arctic Ocean, even in the summertime. But in the last several decades, the amount of summertime sea ice has been shrinking dramatically, both in area and in thickness. And so the Arctic region is, in a sense, becoming darker as you expose more ocean water and you have less ice. So sunlight that might have been reflected off of the white icy surface is now being absorbed into the dark ocean water, heating the ocean, and that is destabilizing the permafrost around the Arctic. And as you mentioned, it's beginning to release methane that has been locked up in the permafrost now for thousands of years. And methane is another greenhouse gas, heat-trapping gas, just like carbon dioxide. And in fact, it's actually a more potent heat-trapping gas. By releasing more of it from the methane, you're simply augmenting the rapid warming. You're accelerating it and losing even more sea ice. I actually think that we have passed the tipping point for sea ice in the Arctic Ocean, and that by mid-century we will see an ice-free Arctic Ocean in the summertime for the first time in human history.
Our final question today, and your answer should be a little short on this, Sylvia. So many people in the world rely upon the oceans for their livelihood and for their health, from sea vegetation and for fishing. And yet, tell us your research, the results, what's happening with the overfishing, the change in the acidification, the dead zones, and other human impact factors that have affected this, and what is the likely outcome if we continue in the way we're going about this?
Well, there's a lot of bad news, in addition to the other bad news we've been hearing. But certainly in the last half-century, our ability to find, extract, capture, market ocean wildlife has greatly increased, and to the point that on the order of 90% of many of the fish that we like to consume have been taken, like tunas and swordfish and marlin and sharks. Only about 10% remain of many of the big species, but it's also true of many of the small ones too. Our capacity to take exceeds the ability of these natural systems to recover. So way beyond, quote, sustainable extraction of ocean wildlife. It's a concern not just because of people who rely on the ocean as a source of their livelihood or to some extent a source of food. It's changing the nature of the ocean itself. Think of trees as carbon-based units. You should think of fish as carbon-based units too. We're really looking at the whole chemistry of the planet, what we're doing to the nature of nature. But the flip side of this bad news is that we know, we now for the very first time have capacity to pull back and see these trends. No one thought 50 years ago that we could take enough wildlife from the sea to make a difference, or that we could use, we thought that the ocean was the ultimate dumping place, so we've used it that way to put things that we don't want on land. Things flow into the sea. We deep six whatever we don't want nearby out in the ocean. But we're now realizing, as you have been pointing out with this program, there are limits to what we can get away with and tipping points that are not in our favor. This is certainly true with what we're extracting from the ocean. We have to greatly reduce the amount of what we are taking from the ocean and what we're putting into the sea without even more dire consequences back to us. There are moves to do for the ocean what has been done to some extent on the land with protected areas, places where we elect consciously to leave the fish in place. And there are benefits that are beginning to be shown as a consequence of this. I think that's good news, that there are things that we can do to alter our behavior, to shift what we do now that we know.
Well, I would agree. Unfortunately, we're out of time, and this program was designed to let you know how serious some of the environmental issues are, and that if you choose to listen to the global or environmental deniers of global human impact, then there's a severe consequence. So my suggestion is educate yourself. From my guest, Professor Henry Pollack, A World Without Ice. From my guest, Professor David Montgomery, Dirt, The Erosion of Civilization. And from my guest, Dr. Sylvia Earle, The World is Blue, How Our Fate and the Ocean Are One. All provide both the problem, but more importantly, the solutions. We will continue with our discussion on an upcoming program. The panelists, thank you all very much for sharing your insights with us. It's greatly appreciated.
Thank you.
Thank you.
Thank you.
I'm Gary Null. Thank you all for watching and listening. I look forward to sharing more on our next Progressive Commentary Hour.